So good evening guys. So welcome to NEET World. So in this session we are going to continue the motion in a plane class. Okay. So in last topic we have seen the motion in a plane, that is projectile motion. Okay. So in this topic which we are going to see is relative motions in like a motion in a plane. Under that relative motion is the next topic. Okay. Relative motion. So we know that motion is nothing but a moving object with reference, like with respect to another object, will say, like a reference frame will say. Okay, object A is there, object B is there. If object A is changing its position from one point to another point, we'll say object A is in motion. Okay, and object B is not changing any position. Now what we will say, object B is in rest. Okay, now the relative motion. Okay, relative motion, separately we have talked about object A and object B, but when I see object B, object A is moving. Okay, yes or no? So relatively I am talking, like what's happening when I watch from B to A or A to B. Okay, that's the main important thing. So under this we are going to see relative displacement or position, will say relative velocity. Okay, relative velocity, and then relative acceleration. Okay, so the main thing when we are talk about relative motion, displacement, velocity, acceleration, like when I talk about motion, displacement is there, velocity is there, acceleration is there. So relative motion, relative displacement, relative velocity, relative acceleration. Okay, now when I talk about relative displacement, so if A is there, object A is there, it has been moved from position 1 to position 2. Okay, so displacement of A is nothing but SA I will denote. Okay, SA. What about B? Then same SB I will denote for B also. Okay, for B. Now the simple formula to remember, when they are asking displacement of position, whatever it is. Okay, if they are asking for position, okay. If they are asking for displacement, okay, whatever it is. Or if they are asking for velocity or acceleration, whatever they ask us, only one formula we are going to follow. That is, if like object A is going with velocity A, okay, or let me consider VA, okay, VA. So object B is going with velocity VB. Now velocity of A with respect to B is equals to velocity of A minus velocity of B. This is the thing. Suppose they are asking velocity of B with respect to A is nothing but velocity of B minus velocity of A. Fine, right? So in this relative motion we should remember one thing is formula. Okay, simple formula. Okay, second thing is the direction of the motion. So direction is nothing but, when I consider this is my positive y axis, negative y axis, positive x axis, negative x axis. When object is going towards right, it is positive, towards left negative, upward positive, downward negative. Okay, first one formula, second one the directions. Okay, same thing for acceleration also. Acceleration of A with respect to B will be equals to acceleration of A minus acceleration of B. What about acceleration of B with respect to A? Acceleration of B minus acceleration of A. Okay, now we are going to take two objects now, object A and object B. Object A is going with velocity VA, object B is going with velocity VB. Okay, now I want to find what is the velocity of A with respect to B and what is the velocity of B with respect to A. Okay, now if I notice here, A is going in positive direction, B is going in negative direction. right now. Wait a minute, okay. So velocity of A minus, okay, that's the formula, but velocity of B is minus, so minus velocity B, which is nothing but velocity of A plus velocity of B. What about in this case? B is in negative case, A is in positive case, so minus VB minus VA is nothing but minus of VB plus VA. Got it? Any doubt in this case? No? Got it now? So simple thing, one is going and other one is going backward. Okay, in that case I have taken both in the same direction, in this case approaching each other. Okay, approaching each other. Now we are going to see main thing here. One is a river boat problem and one more is a rain man problem. This is the important thing in relative motion. Okay, first one, rain boat, it is river. Okay, river boat, sorry, it is not a rain boat, it is a river boat. Okay, river boat problem. Okay, so under this river boat problem now there are two cases. One is shortest distance and one is shortest time. Okay, shortest distance and shortest time. So before that, going into the two topics now, we are going to discuss what is the basic things they are following there. Okay, simple. Let me take two end of the rivers. Like one is this, this is South Bank river, South Bank, and this is North Bank, we'll say. Okay, suppose river is flowing in this direction. Okay, river is flowing in this direction. River is flowing in this direction and person is going along in this direction. Okay, same direction. So which means down the stream, we'll say, going together. Okay, person is going in the direction of the river, which is nothing but downstream. Okay, downstream. So next one is like same river is there, which is of a velocity VR, but the person is going in the opposite direction of the river. This is velocity of the man, and this is velocity of the man, and this is velocity of the river. Okay, now what it called as upstream, will say upstream. I am going in the direction of the river, I am going against the direction of the river. Downstream, upstream. Okay, in both the cases same thing. Suppose if they are asking what is the velocity of a river with respect to man, is nothing but velocity of a river minus velocity of a man. Okay, suppose if they are asking velocity of a man with respect to river is equals to velocity of a man minus velocity of the river. Got it? Okay. In the next case, same. Velocity of the river with respect to man is equals to velocity of the river minus velocity of the man, because velocity of the man is in the direction of negative. Okay, opposite direction, no? So it will be velocity of the river plus velocity of the man. Okay. Now velocity of the man with respect to river is equals to velocity of the man minus velocity of the, minus velocity. Okay, minus VR is equals to minus of Vm minus plus Vr. Okay, got it? Now we will go into the topic now. So suppose, okay, suppose the river is flowing in this direction. Okay, what is the velocity of the river? Let me consider velocity of the river as Vr. Okay, and a person starts swim or going in a boat here. Okay, from this point to this point you need to reach point A to point B. He need to reach. Okay, he is starting in this direction. What happens due to river flow? It will go some, it will go in some angle, right? Yes, no? It will go in some angle. Let me write that if a person starts in this direction, okay, it will go to the point C. Person want to go from point A to point B, but when he starts going, no, due to river flow, he is going to point C. Okay. Now listen carefully. A person going in a boat, okay, going in a boat, we'll consider two persons are there. Two persons are going in a boat and one person is standing here. A person want to go from this point to this point, no. Here two person, 1 and 2. When 2 is seeing 1, they are thinking that they are going in the straight line. Yes, no? But when person 3 is seeing the boat, no, they are going in this direction. Yes, no? Got it? What I can say, this is velocity of the boat with respect to river is in the boat and the boat is in the river. Okay. So they are going in the straight direction, they are thinking. But when the person 3 is standing outside and they are watching, he is watching, no, this boat is going in this direction, which means velocity of the boat with respect to ground. Got it? And this one will be my velocity of the river with respect to ground. Okay, river with respect to ground. Got it? Now, so what are the terms which we are using here now is velocity of the boat, velocity of the river, velocity of the ground. Okay, three things are there. Okay, don't get confused between that. Now let me write velocity of the boat is nothing but, VB is nothing but velocity of boat with respect to ground. Simplify, right? VB, no, it is with respect to ground. Here velocity of the ground is equals to 0, right? Is it moving? No. We are considering velocity of the ground as earth surface. Okay. Either I can write like this or velocity of the boat with respect to ground. Velocity of the boat minus velocity of the ground, which is nothing but VB minus 0. Got it? Now what is the next one? Velocity of the boat with respect to river. So velocity of the boat with respect to river. Okay. Now velocity of the river. Velocity of the river with respect to ground. So or else we can write like this, no, velocity of the river with respect to ground, which is nothing but VR minus VG. Okay, VG is 0. So I can write like this. So this is my diagram, guys. Okay, now think that if I want to go from this point A to point B in a shortest distance, which distance I can use? Point A, A to B I can use. Right now, shortest distance, shortest time in the sense, if I go along with the river, I will reach in shortest time. Okay, so these are the terms which we are going to use in the upcoming topics. Okay, now we will go shortest time or shortest distance. First we will complete shortest distance. Okay. Yeah, shortest distance. Now this is my north bank and this is my south bank of the river. Okay, point A, or let me consider this is my point A and this is my point B. Okay, point B. Or let me explain you before that. Okay, now what I will do is, if I see the diagram, no, if I start in this angle, no, some angle, I will reach in the point. Correct, no? if I start with some angle, I'll reach this point exactly. If I start straight again, I'll go with some angle, right now. So the thing I need to get is here, for the shortest distance, I need to start with some angle. Then I can reach the point C, exactly opposite. So let me consider this is my point A, which makes an angle here, that is theta I will call, okay, or this is B. So wait before writing this one. So exactly if I start like this, I will reach in this manner, no? Yes, no? So this is my this is my point C. Now this is my angle theta over here, okay, theta over here. So the total angle, let me consider that is alpha, okay, alpha. So this is theta, okay. Now I am starting in this direction, I know that, which means velocity of the boat with respect to river. And a person who is standing outside, he watches that I am going in the straight line, but we know that we are going in the angle. So velocity of a boat with respect to ground, and this one similar, velocity of the river with respect to ground, okay. Now the thing which we are going to talk about here is sin theta, cos theta, tan theta, that's it. What is sin theta in this case? Sin theta will be equals to opposite by hypotenuse. Opposite is velocity of the river with respect to ground by velocity of the boat with respect to river, okay. Next one is cos theta, adjacent by hypotenuse, which is nothing but velocity of the boat with respect to ground by velocity of the boat with respect to river, okay. Next one is tan theta. Tan is nothing but sin by cos, which is velocity of the river with respect to ground by velocity of the boat with respect to ground, opposite by adjacent, VRG by VBG, okay. This is the thing, okay. Only this thing we should remember in mind, okay. Yeah. Now shortest time, okay, shortest time. So shortest time in the sense, this is the distance between the two banks of the river, let me consider D, okay. And if I start exactly over here, point A, and point B is this, and point C is this, okay. I am starting in this manner, but I will reach in this point A to B. I am starting, but I am reaching point A to C, okay. Now what I am thinking, like this is my velocity of the boat with respect to river, this is velocity of the boat with respect to ground, velocity of the river with respect to ground, that's it, okay. Same similar, what is sin theta here? Sin theta will be equal to, this is my angle theta, okay, velocity of the river with respect to ground by velocity of the boat with respect to ground, okay. When I compare here, no, it is changing, right? Yes, obviously it is changing. Now cos theta will be equals to velocity of the boat with respect to ground, velocity of the boat with respect, river, ground, okay. Velocity of the boat with respect to river by velocity of the boat with respect to ground. Tan theta is equals to velocity of the river with respect to ground by velocity of the boat with respect to river, okay. It is river, that's it. Now if I want to find the time, no, time, velocity is equals to displacement by time, where time will be equals to velocity into, it is displacement by velocity, okay, displacement by velocity, right, time and velocity, right. Now the shortest time I should find, yes, no, shortest time, which means this velocity I need to get. If I want to go to the point C in a shortest time, this is the velocity I need to use, no. So I can use either sin theta or cos theta, or like VBG, no, velocity of a boat with respect to ground, no. So boat with respect to ground in the sense sin theta or cos theta, either two of the case I can use in this, right. No, how it is, this is velocity of the boat with respect to ground is equals to velocity of the river with respect to ground divided by sin theta. I am using this velocity over here, got it? Or else for this, how I can write? Velocity of the boat with respect to ground is equals to velocity of the boat with respect to river by cos theta. So I can use either this one or this one in the velocity term, okay, velocity equation. Got it? Okay. So let us solve some questions over here and we will go for the next topic, right? Yeah. So train 100 meter long traveling at 40 meter per second. So let me write 100 meter train is there. It's going with 40 meter per second. Another train is 200 meter long. Okay, 200 meter long. So this is 100 meter. This is 200 meter. Traveling with 30 meter per second. The time taken by the first train to pass the second train. Okay, this first train, this is second train. So if I want to pass, no, if I want to touch the front face of the second train, 200 meter I need to take. I need to pass in the sense I need to go, take over that, which means 200 plus 100. So totally 300 meter I need to go. So distance will be, or displacement will be equals to 100 plus 200, which is equals to 300 meter, right? What about the velocity? Relatively I am taking, no? Relatively I am taking. So velocity of the, like what they are asking? Velocity of the first train to the pass the second train, no? So V12 is equals to V1 minus V2, which is nothing but 40 minus 30, 10 meter per second. Now they are asking time, that's it. So time will be equals to displacement by velocity, where it is displacement is 300, velocity is 10, answer is 30 seconds. Got it? You can take down this one. See, 100 meter train is there, okay. For example, a person is standing, like two persons are there, okay. First person is overtaking the second person, which means he need to cross the second person, no. If he is go and standing with, like with respect to first person, is only taking the second person's distance, that's it. If he wants to cross, he want to cross his own body distance also, no. Yes, no. So he is crossing the 200 meter, but he need to take over that. He came up to here, which means he came over 200 meter, but he need to cross, no, he need to cross in the sense again 100 meter he need to go. So here this is the thing I need to calculate. 100 plus 200, 300. Got it? Done? Can we go for the next question? A 150 meter long train is moving north. Moving north in the sense, suppose let me consider, this is my 150 meter train, okay, 150 meter train, moving north in this direction, no, with a speed of 10 meter per second. So moving with 10 meter per second, and a parrot flying towards south. Parrot is flying towards south, which is 5 meter per second. The time taken by the parrot to cross the, cross the train will be, okay. Now they have not given the parrot size, it will be like small thing, but I need to cross the 150 meter, right? Now 150 meter. So which means the displacement will be 150, but velocity, how I can take the velocity? One is in positive, one is in negative, right? Now, which means velocity of the parrot with respect to train, right? No, which is 5 plus 10. I can add directly, no, 15. Both are approaching each other, no. In the case where we have studied, when they are going in the same direction, it will get negative, like it will get subtracted. Okay, when they are approaching each other, they are adding together. Okay, so 15. So time taken will be equals to 150 divided by 15, which is equals to 10. 10 seconds is the answer. Got it? Done. So the next question, can you give answer for this question? Velocity of a B observed by A, which means they are asking velocity of a B with respect to A, VB minus VA. Give answer for this question, we will see. Okay, second one is the answer you got, no? Okay, we will check it. So 3I minus 7J minus of A, no? So minus 2I minus 4J, which is equals to 3, 2 will be 1I minus 7 minus 4, which is minus 11J. So option 2 is the answer. Got it? Okay. Here is the question. Swimmer reaches the other bank, which means he is starting from one side of the river to the other side of the river. Okay, flowing river exactly opposite to the starting point. What they are saying, this is my river, reaches the other bank of the river with exactly opposite point. So he is reaching means point A, this is point C, this is, which he is reaching like this, no, then he should have made some angle to reach over there, which means I should take this diagram, right? No, only two diagrams are there, one is shortest time and one is shortest distance, that's it. If he was swimming at 2 km per hour while maintaining 150 degree, started like this, no, he was maintaining 150 degree, they are saying, okay, maintaining 150 degree. So with respect to the flow, they are saying, no, with respect to the flow in the sense water is flowing in this direction, so which is velocity of the swimmer, no, swimmer are with respect to river. Okay, got it? So with the time taken by him to cross the river, like 1 km wide, they are saying, this is 1 km wide. See, they have given that this velocity, okay, but he has reached point A to point C. So which velocity I should consider? Point A to point C velocity I should consider. This is the thing he have crossed, no, but we have taken the angle and we have crossed. So the thing, this one will be my 90 degree, this one will be my 60 degree, right? Now I will write this one, velocity of the swimmer with respect to ground, velocity of the river with respect to ground. Okay, what is sin theta here? Sin theta will be equals to opposite by hypotenuse. Opposite is velocity of the river with respect to ground by velocity of the swimmer with respect to river. Cos theta will be velocity of the swimmer with respect to ground by velocity of the swimmer with respect to river. Okay, tan theta will be equals to VRG by VSG. Okay, got it, no? Now which one we want? Velocity of the swimmer with respect to ground we want. So in this I can use cos theta easily. Cos theta is nothing but adjacent by hypotenuse. We know two things, theta we know and swimmer with respect to river we know. So velocity of the swimmer with respect to river should be equals to velocity of the swimmer with respect to ground, right? No, I mean, sorry, we need to find velocity of the swimmer with respect to ground, right? Velocity of the swimmer with respect to ground is equals to cos theta into velocity of the swimmer with respect to river. What is they have given? 2 km, right? No, 2 km. So cos 60, 1 by 2 and this is 2. So 1 by 2 into 2, which is nothing but 1 km per hour. Okay, this is 1 km per hour. How much distance? 1 km. So time taken will be equals to distance by velocity 1 by 1, which is 1 hour. Option 2. Got it? You can note this one. Completed. We'll go for the next one. We'll see some more questions for this, okay, this type. So if you solve n number of questions for this cases now, you will get to understand what is the thing they are asking, okay. Two things remember, one is shortest distance, one is shortest time. Shortest distance means you need to make some angle, the first diagram. Shortest time means he will go in the straight, but he will go with some angle, okay. Swimmer crosses a river in a shortest distance. So shortest distance diagram will be like this, no? So this is my shortest distance diagram. Shortest distance diagram, right? No? If he swims at 4 km/h maintaining 120 degree width downstream, so like river is going like this, okay, and he is maintaining 120 degree total. So this is my how much? 4 km/h. What is 4 km/h? Velocity of the swimmer with respect to river. Velocity of the swimmer with respect to ground. Velocity of the river with respect to ground. What they are asking? Speed of the river. I need to find this. Okay. Simple thing. This is my 30 degree. This is 90 means this is 30. Sine 30 should be equals to opposite by hypotenuse. Directly I can get it, no? So opposite, velocity of the river with respect to ground by velocity of the swimmer with respect to river. Sine 30 is 1 by 2. Velocity of the swimmer with respect to river is 4. Will be equals to velocity of the river with respect to ground, 1s and 2s. So velocity of the river with respect to ground is equals to 2 km/h. Got it? Take down. So we'll stop up to this and we'll see some more questions in relative motion in next class, and we'll continue with the rain and man problem too. So once we start doing the problems now and the topic completed now, the motion in a plane chapter will be completed, and we'll see some more questions in that all. Okay? Yeah, thank you.